Welcome to June 14th LeetCode Challenge. Maximum units on a truck. You are assigned to put some amount of boxes into one truck. You are given a 2D array of box types where box type at I is assigned the the list of pairs of number of boxes sub I and the number of units per box sub I. The number of boxes sub I is the number of boxes of the type I. The number of units per box sub I is the number of units on each of the box of the type I. So you're given a integer truck size, which is the maximum number of boxes you could be put on the truck. You can choose any boxes to put on the truck as long as the number of boxes does not exceed truck size. Return the maximum total number of units that we put on a truck. Okay, let's take a look at this example here. We have 3 different types of boxes in our box types, and we have truck size of 4, and we get an output of 8. How is that possible? So we see that we were able to put, let's see, this is box 1 here, and that the unit it contains is 3. So we want to maximize the units, right, and the number of boxes as well. So what we could do is that we could intuitively we know that we want to maximize the amount of units depending on the number of and our limiter is the box numbers, right, number of boxes. So in total, this first number we're going to fit 4 of these. So what is the maximum number we could put? So intuitively you can see by the answer here we could put 1 of these, right, 1 of the first box. We could put 1 of the second box. And then we could put 1 of the last box. So we have right there. So therefore so that means that we have a total of 8. See how we put in 1 of the first box? We have no more of that. We've taken 2 of the second box. We get that. And we have 1 of the last box. So therefore we have a total of 4 boxes in total. And these units are 8. So let's see how we go about solving these. There are hints here which kind of go through the solution, so I won't go through them, but feel free to take a look. So the first thing you want to do is you want to sort your boxes in terms of descending order, right? So the best way to sort your box in descending order would be to let's see. I am gonna modify the box types actually. Box types dot sort, and you want to use the key lambda function here. Lambda, and you want reverse to be true. Alright. So now you want to have, let's say, let's call it total, or what am I saying? Total boxes, or total units, I should say, total units. I'll put the 0, so we initialize a variable for that. So we want to iterate through our box types. So in order to maximize that, I think we're going to use what's called similar to like a greedy algorithm approach. So for boxes and units in box types, or sorted box types, I should say, types. What we're going to do is that if boxes is less than or equal to our truck size, then what we're going to do is that we're going to increment our answer with the number of boxes we have times the unit it has. So our total unit will be, you want to increment it, that will be boxes times the unit. And then once we do the number of boxes times the unit, obviously we're taking a truck size away, so we want to decrement truck size. So the number of boxes is less. If we're able to put boxes on our truck, then what we want to do is take increment the total unit with the boxes that of our sorted list, because we're sorting from the highest unit to the lowest unit, right? So we're optimizing for the biggest bang for our box size. So if that's true, we increment our total units by multiplying the boxes of the unit we have, then incrementing the truck size. So we lose the space in our truck size. So that's what we want to do when we add a box. Else, then what we want to do is that we want to have our total amount. If we can't add any more units to it, then what we want to do is that we want to increment our truck size times the number of units we have, and we're gonna, at the end of all this, we're gonna return. Let's cut it short here. Return total box total unit, because if we don't have enough let's call it size in our truck, then what we're gonna do is we're just gonna increment our total units by having the truck size times the amount of units left. And then we could just exit the loop and return total units. Otherwise, we should return total units here. Okay, let's see if this makes sense. Alright, oh, wait, never mind, we're gonna decrement the number of boxes, not one. Alright, let's submit to see what we get. Okay, accepted. So let's go through the time complexity of this. So the time complexity for this would be, so you have, they're using the sort algorithm, so it's built-in sorting, so it would be, and you have n numbers of boxes, so it would be a big O of n log n for time complexity. And in terms of space complexity, we're sorting, we have a constant time space complexity, because we're not, yeah, it's constant time, constant space, I mean. Alright, that's it. Have yourself a great day.